What is energy? Energy is ability to do work. Um, so, for example, when you throw a ball, ride a bike, or read a newspaper, you use energy to do work. There are two types of energy: potential energy and the kinetic energy. Potential energy is the stored energy. For example, a ball at the top of a hill is an example of potential energy. When the ball rolls down, that stored potential energy is converted to the stored potential energy is converted to kinetic energy, because what is kinetic energy? Energy due to motion. So the ball is moving now, so that's kinetic energy. And we can see from this example that one type of energy gets converted to another type of energy. So this is the law of conservation of energy, that energy cannot be created nor destroyed. It simply changes from one form to another. And or we can say the total energy in the universe does not change. Also, lower energy compounds are more stable. Now, these lower energy compounds are more stable. For example, the energy stored in the ball, or in the, let's say, take another example, in the bond. So here, the energy stored in the bond is the potential energy. Now, lower energy compounds are more stable. That we're going to take a lot of examples on that. But keep in the mind, a compound with a lower potential energy is more stable than a compound with higher potential energy. Next is the units of energy. There are main two types of units that you need to learn: calorie and joule. And look at calorie. In calorie, C is lowercase, calorie, CAL, and joule. And you also need to know the relation between this. 1 calorie equals to 4.184 joule. Now, given the energy in one unit, you should be able to convert it to the other one. For example, let's say you have 25.6 kilocalorie of energy and you want to change it to joules. So again, write down the number that's given to you, draw a line, put 1. Now down here we're going to have the same unit that's up here. Now kilocalorie, first we're going to change it to calorie, and we know what kilo means. Kilo means 1000. 1 kilocalorie equals to 1000 calories. Then down here will be calorie, the same, that's here, and joules here. And then what's the relation between joule and calorie? That you can get it from here. And we can see that 1 calorie equals to 4.184. You cancel calorie with calorie, kilocalorie with kilocalorie. You multiply 25.6 with 1000 times 4.184. That will be your answer. So multiply these three numbers. Energy and nutrition. Now, when we eat food, the proteins, carbohydrates, and fats in the food are metabolized to form simpler molecules that in turn are used to prepare new molecules that cells need for the maintenance and growth. Now, this process also generates energy for the organs to function, for the heart to beat, the lungs to breathe, and the brain to think. Now, amount of stored energy in foods is measured using nutritional calories. And how do we write down this nutritional calorie? With uppercase C. And so this uppercase cal is basically the unit of energy for in which we used with the food items. And 1 cal with uppercase C is equal to 1000 calorie, or 1 kilocalorie. Now 1 gram of this should be 1 gram of protein, or 1 gram of carbohydrate releases about 4 calorie per gram of energy, and 1 gram of fat releases 9 calorie of energy. So for example, let's say you you eat a baked potato, and baked potato contains, let's say, baked potato contains 3 gram of protein, a trace of fat, and 23 grams of carbohydrates. Now, so estimate the number of calories. Now, here 3 gram protein, we know 1 gram of protein releases 4 calorie per gram. So 3 gram protein and 1 gram releases 4 calorie. So 3 times 4, 12 calorie. So we're going to get 12 calorie from protein. Now you also have 23 grams of carb, and this 23 grams of carb, and we know 1 gram of carb releases 4 calorie of energy, and 23 times 4 is 92 cal. So what will be the total? Total will be 104 cal. Now this C is uppercase, it's not a lowercase c. If you have to change it to the lowercase c, you have to multiply this number by 1000. Now, as we discussed, that the energy stored in the bond is the potential energy. Now, if you have a bond and you want to break this bond, then the energy is required for this process. And we call that energy as bond dissociation energy. So energy required to break the bond is known as bond dissociation energy. Now, stronger this bond, higher will be the dissociation energy. So think about it. If bond is strong, means you need to provide more energy to break that bond. Now let's talk about energy, some different types of bonds. For example, let's say we have same elements HCl, HBr, HI, and so on. What I'm doing is I'm taking on this side, I'm taking elements from the same group, which is the 7th group, and on this side is same, which is hydrogen. So what happens when you go down the column like that, then the bond dissociation energy decreases, which means out of these three, it's the easiest one is to break this bond. And why is that? Because when you go down the group, size is increasing. So hydrogen is this size, chlorine is this size, so this is the bond, and then you're making this atom bigger. So when you have too much size mismatch, that weakens the bond, and that means it's easier to break the bond. So keep in the mind that if you are having elements in the same group of the periodic table, then the bond dissociation energy decreases going down the group.
Made with Doodlecast Pro.